day, this is the Professor, CBMD PhD, and today's Monday, July 31st, 2023. It is 2:51 and 1 second, AM Eastern Standard Time, and today's research, structure of polymers. So let's do it here. Material science, how molecular entanglements determine the structure of polymers. Date July 27, 2023. Source: Martin Luther, University. The structure of semi-crystalline polymers largely depends on how strongly their molecular chains are entangled. Following numerous experiments, researchers developed a new model to predict the microscopic structure of the materials as well as their properties. As polymers are long-chain molecules, semi-crystalline polymers are a mixture of solid and liquid elements. They are often used in plastics and packaging materials. When materials cool down, they usually form a crystalline structure at the molecular level. In other words, all the particles are in a tightly ordered pattern. A similar process occurs when semi-crystalline polymers form, except that not all regions crystallize. Instead, there are so-called amorphous regions that have disordered structure after cooling. Here, entanglements that are intertwined with one another are found in semi-crystalline polymers. Ordered and disordered layers alternate over and over on a nano level. This special structure also gives them their unique properties. They are both flexible and elastic, as well as being relatively robust. This makes them particularly suitable as packaging and structural materials. The properties of semi-crystalline polymers largely depend on two factors: the thickness of the above-mentioned layers and how strongly the chains in the amorphous regions are entangled. The scientific investigators and physicists say the factors that influence crystal thickness are already well known, yet knowledge about amorphous layers is still rather limited. And based on their measurements on a model polymer, the physicists discovered that the thickness of the amorphous layers is determined to a large extent by their entanglements. The researchers also developed a simple model to describe this relationship. They assume that their models can be applied to many different polymers. That includes materials that, at the moment, are not used very widely. The new findings could help to improve existing materials or to replace them, either completely or in part, with more sustainable alternatives. And this is the Professor of Space Technology, Applied Physics, Advanced Mathematics, and Leader of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.